Okay, so under theory of equation, আজকের ক্লাসে আমি স্টার্ট করব তোমার হচ্ছে Cardan's method. Okay, Cardan's method হচ্ছে মানে ফার্স্ট টপিক Cardan's method. Under theory of equation, the topic is Cardan's method. Okay, so Cardan's method under theory of equation, এটা আজকে আমরা স্টার্ট করব. So Cardan's method basically what? Cardan's method is solving a cubic equation. Cardan's method is what? Is a method of solving. Is a method of solving a cubic equation. Method of solving a cubic equation, that is called Cardan's method. How we can solve a cubic equation? Basically, কি হয় যে class 8 এ আমরা করেছি vanishing method, okay? In class 8, class 9, we have done vanishing method. Vanishing method is what? Say we are given an equation like this, say x cube minus 3x plus 1 equal to 0. And like them, okay. Say x cube minus 2x plus 1 equal to 0. So how we can solve this equation? X cube minus 2x plus 1 equal to 0. We know if we put x equal to 1, then say that 1 plus 1, 1 cube minus 2 into 1 plus 1, giving you 0. So x equal to 1 is a factor of this equation. After putting x equal to 1, this entire equation becomes 0. So it means x equal to 1 is a factor of this equation. So like this, and then we know how to solve this equation. We have done this in our class 8 or class 9. But now the question is, what happens if after putting x equal to 1, x equal to 2, x equal to 3, and so on, this equation become this equation does not become 0. I can repeat what happened after putting x equal to 1, 2, 3, dot, 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 this equation does not become 0. In this case, our vanishing method, this is our vanishing method. We know vanishing method. We have done this, okay, in our class 8 to 9 course. It's called vanishing method. Vanishing method says what? Vanishing method says put x equal to 1, put x equal to 2, put x equal to 3, and so on, and check whether this equation is 0 or not at this point. Say after putting x equal to 2, this equation becomes 0. In that case, we can easily solve this equation. The method is called vanishing method, a very easy method. But what happens if after putting x equal to 1, 2, 3, 4, 5, 6, this equation does not become 0? Say for example, if we put x equal to 0.1, only then this equation will be 0. Suppose if we put x equal to 0.1, only then this equation will be 0. So how we can find this x equal to 0.1? Can we find x equal to 0.1? Answer is no. It's very difficult to find. It is very difficult to find at what point our equation will be 0. মানে খুব ডিফিকাল্ট যে কোন ভ্যালুর জন্য এই ইকুয়েশনটা 0 হয়ে যাবে. Okay, this is our major purpose of this Cardan's method. So in Cardan's method, it does not matter at what point this equation becomes 0. In Cardan's method, it doesn't matter at what point this equation becomes 0. You don't need to find this point. Instead, we shall proceed in a different way to solve this equation. We shall proceed in a different way to solve this equation. Then this equation is called Cardan's method. Okay, so Cardan's method is basically what? Cardan's method is basically method of solving a cubic equation. So what is the purpose of Cardan's method? It is a method of solving a cubic equation. Where vanishing method does not fit. Vanishing method যেখানে use করা যায় না. If we can't use vanishing method to solve a cubic equation, we shall solve this by Cardan's method. Okay, so what is Cardan's method? We shall start by solving an equation. Okay, we shall go through the concept by solving an equation. Okay, by Cardan's method. So before solving Cardan's method, a most important theory, important result, this result also we have done in our class 11-12 course result. Result is what? Suppose alpha, beta be the roots of an equation. So before solving Cardan's method, we shall discuss this result. We have also done this result in our class 11-12 course. So the result is if alpha, beta be the roots of an equation, and if alpha plus beta is equal to some c, and alpha into beta is equal to some d, this is called sum of the root, and this is called product of the root. So alpha plus beta, this is called sum of the root, and alpha into beta, this is called product of the root. So the theory is, if alpha beta be the roots of an equation, and if my sum of the root is c, and my product of the root is d, then the equation would be, x square minus sum of the root into x plus product of the root is equal to 0. So Cardan's method is a very, very important method, but before solving an equation like Cardan's method, we have to know this result. If alpha, beta be the roots of an equation, so that my sum of the root equal to c and my product of the root is d, then my equation would be x square minus sum of the root into x plus product of the root equal to 0. That is x square minus what is sum of the root? My sum of the root is c, and my product of the root is d is equal to 0. So it's a very, very important equation. If we are given sum of the root and if we are given product of the root, then this is my equation. Okay. Similarly, if alpha square and beta square, now instead of taking alpha beta, we are taking alpha square beta square. Similarly, if alpha square and beta square be the roots, alpha square and beta square be the roots, then the equation would be, my equation would be x square minus sum of the root, one alpha square plus beta square, then product of the root is equal to 0. So it's a very important result. Okay. But we have done this result in our HS course. And so on. It can be alpha cube, beta cube as well. If alpha cube, beta cube are the equation, the equation will be x square minus alpha cube plus beta cube plus alpha cube into beta cube, and so on. So it's my very, very important result related to Cardan's method. So after discussing this result, now we shall solve a question by Cardan's method. এবার আমরা Cardan's method থেকে একটা question solve করব. Okay. So after solving this, now we are going to solve. After stating this result, now we are going to solve an equation by Cardan's method. We shall learn Cardan's method by solving this question. The question ta solve kore amra learn korbo je ki kore Cardan's method use kore. So the question is, first question based on Cardan's method. So question is, solve x cube minus 12x plus 65 equal to 0 by Cardan's method. If we solve this question, our concept will be clear on Cardan's method. Okay. If we solve this question, then our concept will be clear on Cardan's method. The question is solve korle amara concept clear hoye jabe. Okay. So just solve this question. The question is x cube the equation is x cube minus 12x plus 65 equal to 0. You can see that you cannot use vanishing method to solve this question. That means you cannot find a value of x so that this equation will be 0. You can put x equal to 1, you can put x equal to 2, you can put x equal to 3, and so on. You can put any value of x, but you can say that this equation will never be 0. This equation will be 0 for a fraction. For x equal to some fraction, this equation will be 0. But how you can find that fraction? That okay, this is very difficult to find that fraction. That is why we shall discuss Cardan's method. So how to solve Cardan's method? How to use Cardan's method? So in Cardan's method, at first we suppose what is our target? Our target is to find the values of x, right? Solve means what? Solve means we have to find out values of x, right? So basically our target is to find the value of x. Okay. So how to find the value of x? For this, suppose my x equal to some m plus n. Let us take x equal to some m plus n. Mn can be real number. Mn can be anything. Okay. Mn can be anything. Mn can be complex number. Mn can be real number. Mn can be anything. Mn can be integer. Mn can be a fraction. Whatever. So we assume that our target is to find x, right? Our target is to find x. So we assume that our x is equal to some m plus n. So what is our target? Our target is to find the values of m and n. If we can find values of m and n, we can easily find x, right? So this is our target. Our target is to find the values of m and n. This is the purpose of Cardan's method. If we can find m and n, we can easily find value of x because our target is to find value of x. Solve money hoche find out value of x. That's it. So we assume my x is m plus n. Now cubing on both sides. We are cubing on both sides. Cubing on both sides. If we take cube on both sides, then what? See that if we take cube, this is my x cube. This is my m plus n cube. We are taking cube on both sides. So x cube equal to m plus n whole cube. This implies x cube equal to, now this is the formula of a plus b whole cube. There is a cube plus b cube plus 3ab into a plus b. This is the formula of a plus b whole cube, no? A cube plus b cube plus 3ab into a plus b. We know this theory. Okay. We know this theory. This is the formula of a plus b whole cube. It's a very easy theory. Then what? This implies x cube minus 3mn into m plus n. What we are doing? We are taking this part to the left hand side, also this part to the left hand side. Basically side change. That's it. We are taking minus 3mn into m plus n to the left hand side, then minus of m cube plus n cube to the left hand side, like this. Taking all part to the left hand side, giving you x cube minus 3mn. Now what is m plus n? M plus n is x. See that? What is the value of m plus n? M plus n is basically x. See, m plus n equal to x. See. And m cube plus n cube remain as it is. This m cube plus n cube remain as it is. So taking all the parts to the left hand side, and we are putting m plus n equal to x, and m cube plus n cube remain as it is. So say there is my equation number 1, and the given equation, we are given what? We are given x cube minus 12x plus 65 is equal to 0. Say this is my equation number 2. So these are my equation number 1 and 2. So this is my Cardan's method. This is a method of solving an equation by Cardan's method. Method of solving an equation by Cardan's method. So after cubing on both sides, we find an equation like this. This is my equation number 1, and this given equation is equation number 2. Now see that if we compare between 1 and 2, if we compare between 1 and 2, comparing comparing 1 and 2. What happens if we compare 1 and 2? Comparing 1 and 2, see that my coefficient of x is minus 3mn. My coefficient of x is minus 3mn. And here my coefficient of x is minus 12. Right? Here my coefficient of x is minus 3mn. And here my coefficient of x is minus 12. This gives you my mn. 3 and 12 gets cancelled. My mn becomes 4. My m into n becomes 4. Finally, see that here my constant term is this. This is my constant term. This is my constant term. And here also my constant term is 65. This gives you m cube plus n cube is equal to minus 65. Right? So we are getting to equation m cube plus n cube equal to minus 65 and mn equal to 4. Also see that from this equation, if we take cube on both sides, from this equation, if we take cube on both sides, mn cube, that will be m cube into n cube. See that? Mn whole cube. Mn whole cube is what? That will be m cube into n cube. And if we take 4 cube means 64. Why we are taking cube on both sides? What is the logic behind taking cube on both sides? So we are getting to equation. There is my constant term 65, and my constant term is minus n cube plus n cube. We are comparing them, and we are getting n cube plus n cube equal to minus 65, and m cube into n cube equal to 64. So we are getting two equations like this. Now, why we are taking cube from this equation? Why we are taking cube on this equation? Answer is very clear. See that if we take m cube as alpha, okay, in rough work, if we take m cube as alpha and n cube as beta, say, if we take n cube as alpha and n cube as beta, then there is my alpha and there is my beta. So we are getting alpha into beta equal to 64. And this is my alpha. This is my beta. So we are getting alpha plus beta equal to minus 65. And alpha into beta equal to 64, right? See that? After taking m cube equal to alpha, n cube is equal to beta. What we obtain is alpha plus beta equal to minus 65. Alpha into beta equal to 64. That's it. Done. Okay. So we are getting this too. See that my alpha plus beta is minus 65. Alpha into beta equal to 64. So where alpha is n cube, beta is n cube. So this gives you what? This gives you alpha and beta are the roots. Alpha and beta are the roots. Right? There is the main thing, na? Alpha and beta are the roots. Roots of what? Roots of the equation x square minus sum of the root into x plus product of the root equal to 0. We know this thing. If we let alpha is equal to m cube, beta equal to n cube, then alpha and beta are the what? Alpha and beta are the roots. Roots of what? Roots of this equation x square minus sum of the root into x plus product of the root equal to 0. Right? Now, what is my alpha? My alpha is n cube. And my beta is what? My beta is n cube. So this gives you x square minus m cube plus n cube into x plus m cube into n cube is equal to 0. Say that. From this, what we obtain? We are putting their respective value. My alpha is n cube, my beta is n cube. Right? So x square minus n cube plus n cube plus n cube into n cube is equal to 0. After putting alpha equal to n cube, beta equal to n cube. And from this, my m cube plus n cube is minus 65. And my m cube into n cube is 64. That is equal to 0. This implies x square plus 65x plus 64 equal to 0. X square plus 65x plus 64 equal to 0. Now from this, we can use middle-term factor. From this, we can use middle-term factor. Middle-term factor says it can be written like this: 64x plus x. We are writing 65 as 64 plus 1. 64 plus 1 giving you 65. Then if we take x common, x into x plus 64, then x plus 64, then 1 is equal to 0. So x plus 64 into x plus 1 equal to 0. Okay. Oh, actually, one thing is you cannot use x here because x is already present here. Here x is already present, so you can't use x again. So let it let it be some y. Okay. Just replace x by y. In all these steps, replace x by y because x is already present here. Okay. So since x is already present here, so we are writing or we are replacing this as y. That's it. In all these steps, just replace x by y. You can take z as well, whatever be your. So it gives you y equal to minus 64, y equal to minus 1. So y equal to minus 64, y is equal to 1, minus 1. So these are roots. These are roots of this equation. Okay, roots. That means these are my alpha beta. Because we assume alpha beta are the roots. So these are my roots of this equation. So roots are minus 64 and minus 1. That means one of them is alpha and another is beta. Anyone can be alpha, anyone can be beta. Because these two values gives what? These two values gives us simple root. That means these are my alpha and beta. That's it. These are my alpha and beta. So this is my alpha and this is my beta. Assume that. Okay. Assume this is alpha, this is beta. Let alpha is equal to this because these are my root. They can also take this is alpha, this is beta. This is your choice. And my alpha is what? My alpha is m cube. And my beta is what? My beta is n cube. So my m cube is minus 64. Okay. So our result is m cube. This is equal to minus 64. M cube equal to minus 1. Because these are my roots. And the roots are alpha and beta. We have assumed the roots are alpha and beta, where alpha is m cube, beta is n cube. So very, very important part. Okay, so very, very important part. My roots are m cube and n cube. And these are this. My m cube is this, my n cube is this. Then what? Then we know our result. We know our result under complex number. The result was, we know this result under a complex number. The result was, if x is 1, then what is the cube root of 1? What is the cube root of 1? Basically, that means what? 1 to the power 1/3 is what? If x is 1, then what is cube root of 1? Cube root. We know this theory, some complex number. The result is cube root of 1 is 1 omega square. This is the result that we have done in complex number chapter. cube root of 1, there is always 1 omega omega square. It is always true, 1 omega and omega square. Okay. So this is called cube root of 1. For example, what is cube root of 8? There is 2 omega, 2 omega square. We know this theory from complex number chapter. What is cube root of 27? There is 3 omega, 3 omega square. Okay, we know this result from our chapter complex. So we shall apply this result here. How we can apply these results in this problem? Answer is, suppose my m cube is equal to minus 64. Minus 64, then m is what? M is minus 64 to the power 1/3. Now, what is cube root of minus 64? It is minus 4. What is cube root of minus 64? There is simply minus 4. Okay. We know cube root of 64 is 4. So cube root of minus 64, that will be minus 4. So cube root of minus 64 will be minus 4 omega minus 4 omega square. Simple theory. Similarly, n cube is equal to minus 1. This means n equal to minus 1 to the power 1/3. And what is cube root of minus 1? It is minus 1. Then the cube root of minus 1 to the power 1/3 will be minus 1 into omega minus 1 into omega square. See that these are my values of m and n. Now the last step and the major step. These are my values of m and n. Now what is our prime objective? Our prime objective is to find the values of x. See that what is the prime objective? The prime objective is to find the values of x equal to m plus n. My target is to find values of x and my x is m plus n. So we have to add m and n. We have to add m and n. How we can add m and n? See that we have to add m and n by satisfying the equation. Recall, we have equation mn equal to 4. We have equation mn equal to 4. So we have to find out values of m and n by satisfying this equation m into n equal to 4. For example, see that. For example, let us take m equal to minus 4, n equal to minus 1. Minus 4 into minus 1. If we multiply them, there is my m, there is my n. If we multiply them, see that m into n giving you 4, this condition is satisfied. So we have to add minus 4 with minus 1. You have to add m and n. I again repeat, you have to add m and n such that this condition is satisfied. M into n is equal to 4. For this, if we take m equal to minus 4 and n equal to minus 1, see that if we multiply m and n, minus 4 into minus 1, that will be 4. Right? So you have to multiply them by satisfying this condition only. We must satisfy this equation. Right? So our first x, our first x is x equal to m plus n. We are taking m equal to minus 4 and n equal to minus 1. So this is my minus 5. So minus 5 is a root of this equation, right? Minus 5 is a root of this equation. Next. Now let us take m equal to this and n equal to this. That means this with this. See that if we take m equal to minus 4 omega and n minus 4 omega and n equal to minus omega square. If we take m equal to this and n equal to this, then what is my m into n? My m into n is minus 4 omega minus omega square. Then minus a minus a plus 4 into omega square, giving you omega cube. And we know omega cube is 1. So again, this condition is satisfied. M into n equal to 4. That means if our m is this, my n will be this. You can't take m equal to this and n equal to this, because you can see that their product is not 1 and n is not 4. Okay, if you take m equal to minus 4 omega, n equal to minus omega, if we take m equal to minus 4 omega and n equal to minus omega, and then if you multiply m and n, see that it is minus 4 omega and it is minus omega. Their product is 4 omega square. It is not equal to 4. So this condition does not satisfy. But as we know, we must satisfy this condition, m into n equal to 4. So we must take m equal to this and n equal to this. That is why we have taken m is equal to this and n equal to this, so that their multiplication gives you 4. See that their multiplication gives you 4. So my second x equal to this plus this. So minus 4 omega minus omega square. Minus 4 omega minus omega square. This is my another value of x. Okay. Since there is a cubic equation, there is a cubic equation. There are 3 roots. There is a cubic equation. So it has 3 roots. There is my first root. There is my second root. And obviously my third root. My third root will be add this with this. My third root will be add this with this. Minus 4 omega square minus omega. Obviously, if we multiply these two, you can see that their product will be 4. Do it yourself. If we multiply these two, their product will be 4. So this is my third root. So these are the roots of this equation. One is minus 5, second is minus 4 omega minus omega square, and my third is minus 4 omega square minus omega. Okay. So these are my roots of this equation. Okay. So similar question. There are variety of projects on this chapter. Similar second question. Okay. Now the second question is quite different. There is also Cardan's method, but there is a slight problem in this question. This question is easy because of the step Middleton factor. Because of the step Middleton factor, in the previous question, we find m equal to minus 1 and minus 64. Y. In this question, we find y is equal to minus 1 minus 64 by using Middleton factor. But what happens if Middleton factor does not valid for this question? What happens if we can't use Middleton factor or Middleton factor is not valid? In that case, how we can solve the question? Okay, in the previous question, we have easily solved this question by using Middleton factor. Okay, this was my equation, 65x plus 64. From this step, okay, this was this step from our previous question, and we solved this equation by using Middleton factor, like y square plus 64x plus x plus 64 equal to 0. Now, this is called Middleton factor method. But what happens if Middleton factor does not fit? Now, there is the second type of variation from Cardan's method. If Middleton factor does not fit, how we can solve the question? So, there is my second question. Second type of question from this chapter. The second question from this chapter, the question is solve x cube minus 6x minus 4 equal to 0 by Cardan's method. Second question from Cardan's method is solve x cube minus 6x minus 4 is equal to 0 by Cardan's method. Now this question is quite different, but almost similar to previous question. But there's a slight difference. Solution. As in the previous question, we assume let x equal to m plus n. Okay, this is similar to my previous question. We assume x equal to m plus n, and then cubic on cubing on both sides. This is my x cube. There is my m plus n cube. Okay, we are taking cube on both sides, so x cube equal to m plus n whole cube, and m plus n whole cube is a cube plus b cube plus 3ab into a plus b. This is the formula of a plus b whole cube, and take all of them to the left hand side. X cube minus 3mn into m plus n minus m cube plus n cube equal to 0. Proceed to solve this question like the previous question. So we are taking all these factors to the left hand side. Okay. So x cube minus 3mn into m plus n minus m cube plus n cube equal to 0. Then see that x cube minus 3mn. Now what is m plus n? M plus n is x. See that my m plus n is x, and m cube plus n cube, it's remain as it is. This part remain as it is. X cube minus 3mn, my m plus n is x, and my m cube plus n cube, okay, it remains as it is. And my given equation is given x cube minus 6x minus 4 is equal to 0. Equation number 2. X cube minus 6x minus 4 equal to 0. Now if we compare, again if we compare, comparing, see that my coefficient of x is minus 3mn, and my coefficient of x is minus 6. See that we are comparing, my coefficient of x is minus 3mn, and my coefficient of x is here minus 6, giving you mn equal to 2. Mn equal to 2. This equation is very important equation. And again, my constant term is minus m cube plus n cube, and here my constant term is minus 4, giving you m cube plus n cube is equal to 4. So these are the equations, and they know we have to cube on both sides. So cubing on both sides, m cube into n cube, and 2 cube is 8. Why we are taking cube on both sides? We know this theory. Let us take this one as alpha, this one as beta. This portion is almost similar to my previous question. So there is my alpha, there is my beta. So what we are getting? Alpha plus beta. Alpha plus beta is equal to 4. Alpha plus beta is equal to 4. Then alpha into beta is equal to 8. Alpha plus beta is equal to 4. Alpha into beta is equal to 8. This means what? This means alpha and beta are the roots. This is my sum of the root. This is my product of the root. So giving you alpha and beta are the roots. Alpha and beta are the roots of the equation what? Y square minus sum of the root into x plus product of the root is equal to 0. This implies y square minus, what is my sum of the root? My sum of the root is 4. So y square minus sum of the root, my sum of the root is 4 into x, my product of the root is 8. Now the main part. Now we obtain this equation, you can see that you can't use middle term factor, because here it is 4 and here it is 8, and 4 is less than 8. 4 is less than 8. So you cannot use middle term factor in this question. So how we can proceed this question? Now how to proceed in this question? See that here we shall apply Siddharacharya method. Siddharacharya method, we know Siddharacharya method. We can apply Siddharacharya method. Siddharacharya method says what? Sidra-Churya method says we can write y as, what is the rule of Sidra-Churya method? Rule is minus b plus minus root over b square minus 4ac by 2a. This is my Sidra-Churya method, minus b plus minus root over b square minus 4ac by 2a. So this is my b. Coefficient of x is called b. Coefficient of x is b. So minus of my b is what? My b is minus 4 minus b plus minus root over b square minus 4 into my a. My a is coefficient of y square. Coefficient of y square is a and my c is 8 by 2 into my a. My a is again coefficient of y square. So there is a rule, minus of b. My b is minus 4 plus minus root over. My b is again minus 4. So b square minus 4 into my a is 1. My c is 8 by 2 into a. Well known Sidra-Churya method. Okay, well known Sidra-Churya method. So then if we solve this gives you value of y become minus a plus 4 plus minus root over 16 minus 32 by 2. Root over 16 minus 32 by 2. Okay, yes. So this gives you y equal to 4 plus minus root over minus 16 by 2. Now root over minus 16, root over 16 is 4. See that this gives you 4 plus minus root over 16 is 4. But since there is a minus sign in root over, that will be I. Because we know I equal to root over minus 1 is I. Since there is a minus 1 in radical sign, so there will be I. And root over 16 is 4. So this becomes 2 plus minus 2i. So see that now my root become complex. Okay, this is the difference from previous question and this question. My root become complex. These are the varieties in Cardan's method. Either our root can be real. Okay, either our values of y. So these are my values of y. Sorry. So these are my values of y. So my values of y are 2 plus minus 2y. So this is the main difference between previous question and this question. My y become complex and my previous question y was real. The value of y was minus 64 minus 1 in my previous question, but now they become complex.
Sir, in the equation, shouldn't it be y square minus alpha plus beta into y? So you have written x there.
Sorry?
Sir, shouldn't it be y? Because like in the quadratic equation, there should be one variable. And you have used 2 in that equation.
Y square, that means there are 2 roots.
Yes, these and there's alpha plus beta into x is written there.
Huh. My alpha plus beta was 4. My alpha plus beta was 4. 4 into x plus 8. Oh, that will be y. Okay. That is very simple. Okay. So my values of y was 2 plus minus 2y. So these are my roots. So one of them has alpha and one of them are beta. So let this is my alpha. Say this is alpha and say this is beta. Say these are my alpha. Okay, this is why very simple. This is very easily understandable. So these are my alpha and beta. So alpha is 2 plus 2y and beta is 2 minus 2y. So, and we know alpha is what? Alpha is m cube and beta is n cube. So this gives you my m cube. M cube is 2 plus 2y and n cube is 2 minus 2y. Okay. So these are my m cube and n cube. Now how we can find m and n from this? From m cube is equal to this and n cube is equal to this. How we can find m and n? There is the main question from this. Okay, so see that MQ, at first we start with MQ. Similarly, you can find MQ. MQ is this, take 2 common. If we take 2 common, then this will be 2 into 1 plus I. 2 into 1 plus I. Okay. Then how we can find this? Or for this type of question, see that this is my real part. Always take real part as r cos theta. Always take real part as r cos theta. This is a very, very important trick. And imaginary part, this is my imaginary part. What is the coefficient of imaginary part? Coefficient of imaginary part is again 1 and 1 equal to r sin theta. This is always true. Always take real part as r cos theta, and always take imaginary part as r sin theta. Always. Okay, there is no other rule. Real part as r cos theta and imaginary part as r sin theta. Then take squaring and adding. Squaring and adding. If we take 1 square plus 1 square, then this will be r cos theta square r sin theta square. We are taking square and adding. Squaring and adding. This gives you what? 1 square plus 1 square gives you 2. 1 plus 1 is 2. Then this is my r square. If we take r square common, this will be sin square theta plus cos square theta. This implies r square is equal to 2 and r equal to root 2. See that r cannot be negative. Okay, because in complex number, r denote their modulus. We know this from complex number chapter. R denote basically modulus of z, and there is always a positive number. So r is equal to root 2. So my value of r become root 2. So we substitute the value of, okay, so if you and what is theta? What is theta? So divide these two equations, divide. And dividing see that 1 by 1. My 1 is r sin theta and this 1 is r cos theta. Always find by this rule. 1 by 1 gives you 1. R gets cancelled. Sin theta by cos theta gives you tan theta. And tan theta equal to 1 mane theta equal to pi by 4. Is very well known. Tan theta is equal to 1 mane ki hobe? Theta is equal to pi by 4. Is very well known. So you obtain value of r and theta. My r become this, my theta become this. Okay. So these are my r and theta. Now what? Now our objective is to find MQ. Similarly, we can find MQ. Exactly similar way. So for my MQ, therefore my MQ is what? MQ is 2 into 1. 1 is equal to r cos theta. My real part is r cos theta. And my imaginary part means coefficient of I. My imaginary part is r sin theta into I. Okay, we are just substituting their values. My real part is r cos theta, and my imaginary part is r sin theta. This I remain as it is. So this is equal to 2 into. Now if we take r common, my r is what? My r is root 2. My r is root 2, and there is my cos. My theta is pi by 4. Here also my theta is pi by 4 into y. We are taking r common. And if we take r common, my r is root 2 and my theta is cos pi by 4. And sin theta is again pi by 4. So this gives you m cube is equal to 2 root 2. This means 2 to the power 3 by 2. And cos pi by 4 is 1 by root 2. And there is sin pi by 4 again 1 by root 2 into y. 2 into root 2 means 2 to the power 3 by 4. Okay, actually, you don't need to put the value of cos theta. It will be easy for us. Okay, let it be cos pi by 4 in this form. You don't need to put this cos pi by 4. Sorry. Just let it in this form. So just 2 root 2 means 2 to the power 3 by 2. And let it as it is. So there is my n cube. Right? There is my n cube. Similarly, my n cube. There is my n cube. My n cube will be 2 to the power 3 by 2 into cos pi by 4. See that we have a minus sign. So minus of I into sin pi by 4. Exactly similar way we can find this n cube. Okay. So these are my m cube and n cube. Now there is a result. We have done this result in our complex number chapter. Again, there is an important result. See, exactly similar way you can find n cube like this. Exactly similar. There is no change. Because there will be a minus sign, that's it, and there's a plus sign. So there is my m cube and n cube. M cube and n cube. Now we shall apply a result. Result is, we know cos theta is equal to cos twice k pi plus theta. We have done this in our complex number chapter. Cos theta is equal to cos twice k pi plus theta, where k is an integer. K is an integer. We know this result from complex number chapter. And sin theta, it also can be written as sin twice k pi plus theta. Again, my k is an integer. So these are results from complex number chapter. And cos theta is equal to cos twice k pi plus theta, and sin theta is equal to sin twice k pi plus theta. Now, if you use this result, we can simplify m cube and n cube. What is my m cube? My m cube is 2 to the power 3 by 2 cos pi by 4 plus I into sin pi by 4. Now, the result is, this is my theta. These are my theta. So, what is my result? My result is cos theta is equal to cos twice k pi plus theta. Okay, this comes from this result. We have done this result from our complex number chapter. Cos theta is equal to cos twice k pi plus theta plus I into sin theta is equal to sin twice k pi plus theta. These are my m cube and n cube. My m equal to 2 to the power 3 by 2, then cos theta equal to cos twice k pi plus theta. I sin theta equal to sin twice k pi plus theta. These are my m and n. So my m, this is my m cube. So my m is what? M is 2 to the power 3 by 2 cos 2k pi plus pi by 4 plus I into sin 2k pi plus pi by 4 whole to the power 1/3. This is my m cube. This is my m cube. So what is my m? My m will be this to the power 1/3. This, this 2 to the power 3 by 2 also comes under this to the power 1/3. See that? So my m cube is this. What is my m? My m will be this to the power 1/3. and this entire thing to the power 1/3 by laws of indices. This to the power 1/3 and this entire bracketing portion to the power 1/3. Because this is my n cube. So this is my n. This to the power 1/3 and this to the power 1/3. So after simplifying, so here see that 3 gets cancelled. There is 2 to the power half. And by de Moivre theorem, recall de Moivre theorem. De Moivre theorem says what? 1/3 can be multiplied with this. 1/3 can be multiplied with this. See that my 1/3 can be multiplied with this. Similarly, here also I into sine. This 1/3 can be multiplied with this. So this is my de Moivre theorem. This power will be multiplied with this angle. This is called de Moivre theorem. We can always multiply this power with this angle. So 1/3 is multiplied with this and 1/3 is multiplied with this. So this is my value of m. Okay, right? This is my value of m. So similarly, my n is what? This is my n cube. So exactly similar way, we can find that my n equal to 2 to the power half cos 1/3 minus. See that there is a minus sign. That is why there is a minus. Exactly similar way, we can find n equal to this. This is my n. So these are my m and n. These are my m and n. Okay. Now see that what is the range of k? Achha, okay. So before discussing the range of k, my final step is what? What is my x? Recall, my x is what? My x was m plus n. X equal to m plus n. Where m is this and n is this. So m plus n. Put the value of m. My value of m is this. Value of m is 2 to the power half cos 1/3 into twice k pi plus pi by 4 plus of 2 to the power half into I into sine 1/3 into 2k pi plus pi by 4. This is my value of m. This entire thing is my value of m. This is my value of m plus value of m. This is my n. Put the value of n. My n is 2 to the power half cos 1/3 into 2k pi plus pi by 4. Then minus 2 to the power half into I into sine 1/3 into 2k pi plus pi by 4. Just putting values of m and n. This entire thing is my value of m and this entire thing is my value of n. Okay. These are simply my values of m and n. Now, see that you can easily see that this portion gets cancelled. Plus minus gets cancelled. So what we obtain? This plus this, giving you 2 into 2 to the power half into cos. Just adding them. Just addition. After adding them, we are getting this. Okay, done. and 2 into 2 to the power half. Similar, this gives you 2 to the power 3 by 2. And there is my cos 2k pi by 3 plus pi by 12. Okay, so there is my final solution. This is my x. Now, what is k? What is the range of k? As we have discussed in complex number chapter, see that there is a cubic equation. The question is what? Question is x cube minus 6x minus 4 equal to 0. So there is a cubic equation. That means this equation has 3 roots. This equation has 3 roots. How we can obtain 3 roots? See that my k is an integer. So if we put k equal to 0, because 0 is an integer, if we put k equal to 0, we shall get first root. If we put k equal to 1, we shall get second root. If we put k equal to 2, we shall get the third root. So the range of k will be 0, 1, 2. Because for sake of simplicity, we always take k as positive integer. Okay, k positive, okay, only positive side. But 0 is also an integer. Obviously, 0 is also an integer. Because this theory, whenever we have discussed this theory, cos theta is equal to cos 2x k pi plus theta, we have assumed my k will be 0, 1, 2, dot, dot, dot. We have discussed this in our complex number chapter. Just go through my class copy. You can easily understand this concept. So in this case, we always take k as positive integer, 0 as well, because 0 is always an integer. Always remember, 0 is an integer. So if k equal to 0, we shall get 1 root. If k equal to 1, we shall get my second root. And if k equal to 2, we shall get our third roots. So these are my 3 roots of this equation. And see that these are my roots. And we have used complex number to find these roots. Okay. So there is everything for my Cardan Method chapter. Range of k. Range of k, basically we always take k as integer and positive integer. So if we take k equal, there are 3 roots. There are 3 roots. That means k must take three values. Since this equation has 3 roots, k must assume 3 values. So one root is obtained by taking k equal to 0, because 0 is my first integer. And since we have taken positive integers only, if we put k equal to 1, we shall get our second root. If we put k equal to 2, we shall get our third root. For example, see that if we take k equal to 0, my first root is 2 to the power 3 by 2, then k equal to 0, so this becomes cos pi by 12. This is my first root. If we put k equal to 1, my second root, this will be 2 to the power 3 by 2 cos k equal to 1. So 2 pi by 3 plus pi by 12. This is my second root. And similarly, if we put k equal to 2, we shall get my third root. So these are my roots of this equation. We have used complex numbers. So everything is from Cardan's method. These are 2 varieties from Cardan's method. And okay, take 2 homework from this chapter. First homework question. First homework is x cube minus 24x plus 72 equal to 0. X cube minus 24x plus 72 equal to 0. Then second question is, just a minute, x cube minus 3x plus 1. And third question, take another question. x cube plus 12x. No, sorry. X cube plus 12x, right? Minus 12 equal to 0. So take these three questions for practice from Cardan's method, and for any problem you can ask me. Okay. So these are three important questions for homework only.